Today we'll talk about Natural Instrument LabVIEW. LabVIEW is a graphical programming language that is used in many laboratories and industrial fields. Every company that you can imagine uses LabVIEW in some way. LabVIEW is a growing trend in programming because it's use graphical programming instead of codes and lines of codes. So, programming language timelines, it's begin with machine code 0101 binary code. Also in low level language, then it go like assembly HDL. Also we have high level textual language C++, basic PHP, and now we have high level graphical languages like Simulink, IGLB, Flowcode, and last LabVIEW. Okay, LabVIEW, if you are going to choose any programming language, you have two sides to decide in them. The first one is abstraction, and the second side is performance. Depending on these two reasons, or two skills, you should decide which programming language you should use, depending on performance and abstraction again. Okay, now if we are going to talk or to say what is LabVIEW, what you mean by LabVIEW. A lot of people don't know what is LabVIEW. LabVIEW is a laboratory virtual instrument engineering workbench. It is a combined of an ILVIS PCI system, an I compounds, an I speedly. It's a laboratory program that is used to connect all laboratory instruments in one program. It's provide data acquisition and vision, computer vision, and speech control, speech recognition, control, simulation and mechatronics, circuit design and simulation, measurement and instrumentation, signal and image processing, NI, and wireless communication, embedded system design, prototype, deploy. And these are prototype, deploy, and design, simulate. These are in design, simulate circles, and this is in prototype and deploy circuits, because these are instruments that MI has developed, like MI Speed 33, DSP, starter kit, MI Elvis, and a lot of instruments that National Instrument developed. So National Instrument is a very powerful programming tool because it has its own products or instruments that if you are going to use LabVIEW, it will be better and more powerful because it's the same programming language of the system. So you can program the code and move it to the instrument, an I instrument, or you can make an interface with any instrument that is not an ILVIS products, like example Arduino PLCs, any kind of PLCs, and any kind of instruments, PLC, Arduino microcontroller, temperature sensor, any kind of instrument. The LabVIEW provide you an interface or a module to interface with them and to data acquisition and acquisition information from them. So compile the graphical development environment, develop time reduction of 4 to 10 times. Using a graphical development environment, save 4 to 10 times of using any other programming language. Tools to acquire, analyze, and present data. Okay. LabVIEW. LabVIEw embedded platform from National Instrument. High-level design modules have can be on desktops and have a real-time or in mobile vision, DSPs, MPU, microcontrollers, FPGAs, and PLC touch screens. All these are LabVIEW are supporting them and have modules and categories for them. Also, you can program in textual math like MATLAB code in LabVIEW, or you can code by C HDL code or Simulink, or you can program by data flow, IPs, and state charts. Okay, also LabVIEW can provide you a graph or signal platforming like an oscilloscope. You can show you a signal that it comes from anywhere and plot it on the screen. Okay, why LabVIEW? Because 110 countries around the world are using it, because it has a plus 40 branch, 5,000 employees, 7,050 and 500 universities, 1,000 universities in the USA, 150 textbooks are describing LabVIEW. So it's and this are from 2011. So there is a lot of difference and increasing of these numbers. This make the customer comfortable and have that the support will not end, and you will have time by time development of the products, and they will have a customer support and a collaboration with the company, so you will feel comfortable to deal with them. Okay. Also, all of these companies are using LabVIEW. Ford, Sony, Motorola, Siemens, HP, AMD, Honda, Intel, all of these companies and more are using LabVIEW. Okay. Diversity of application of LabVIEW are diversity for telecom, automotive, semiconductors, electronics, computers, IT, military or aerospace, advanced research, petrochemical, food processing, or textiles. Okay. Traditional prototyping tools, you was need to a lot of circuits and a lot of control circuit and electronics and things. Now in the graphical system you just code in a formal way and make it a connection with the computer, so all the processes are done on the LabVIEW graphical simulation, or you can use it like a real accommodation. Okay. Data acquisition is getting information from outside or from physical institution and move it to the computer for processing and acquiring data and displaying it using an oscilloscope, two parallel loops for acquiring data and displaying it using an oscilloscope, two parallel loops with different rates of acquiring data and displaying it using an oscilloscope. In lines it was 13 pages, 700 lines. In LabVIEW it's just two loops, small loops that will take from you just 1 to 1.5 minutes, so it's excellent. Acquiring analog data from FPGA pin and storing it, you will need in coding 66 pages, 400 lines in LabVIEW, just as we see. Why we don't use LabVIEW then? Okay. LabVIEW fundamentals, data flow programming, both simulate signal, express with execute simultaneously, comparison weights until all inputs are present, then execute. Like a tree or a binary tree, you need all inputs to come here. For example, this will generate a signal and this will generate a signal, then this, when inputs are comes, will generate an output. Okay. Once executed, output from comparison continues through code. Okay. Data flow diagram executing is dependent on the flow of data. Block diagram does not execute left or right. Node executes when data is available to all input terminals. Node supply data to all output terminals when done. If the computer running this code had multiple processors, these two pieces of code could run independently without additional coding. Okay, the LabVIEW environment, VI, means virtual instrument, program or function. This is the front panel. It's the user interface, the graphs you will see, the user, the screen that the user will deal with it. Block diagram, it's simply the code. Okay, it's simply the code. Here you make a connection between these elements and tell each one what will do. Okay, what is virtual instrument, VI? Front panel, it's a VI composed of three things. The first one is front panel, user interface, controls equal inputs, indicators equal outputs. Also we have a block diagram, graphical source code, data travels, graphical source code, data travels on wires from control terminal through function to indicator terminals. A block execute by data flow. Icon or connector, a graphical representation of a VI means of connecting VL sub VIs. Okay, we will describe what is icons and connectors later. Also we have what is controls and indicators. Control indicators may be knobs, dials, graphs, charts, buttons, digital display, slider, thermometers. Customize and create your own. Okay, as we said before, controls is for inputs. The user will, for example, this knob is an input, it's an control. This graph is an indicator, this is an indicator and maybe can be a control. This lid is an indicator, this bottom is a control. Okay, finding front panel object. If you click right click on front panel, browse by object hierarchy. Press Ctrl space to bring up search by object name. Okay, executing control structure. There is a while loop and for loop. This is run times n, and this is the iteration that has been done until yet. While loop, this is a number of iteration, and this is a conditional stop button when the loop will stop. Allow same piece of code to run multiple times, exit condition different for each. Okay, common data type found in LabVIEW. Each the data type has a different color. For example, Boolean has a green color, integer has a blue color, orange color for double and array, but the thickness of the line is different. For dynamic data, it's blue that is cutted, error cluster yellow, string is pink. Wires and data types. Transfer data between a block diagram object through wires. Wires are different, the different colors, style, and thickness depending on their data type. A broken wire appears as a dashed black line when with a red X in the middle. This means there is a broken wire appears. This means that there is an error in the code. This is means the thickness and the color mean another thing. Okay, LabVIEW key features. Hardware, you can hardware integration, input and output communication, connect to any instrument on sensor with built-in libraries and thousands of instrument drivers. Plug and play hardware, seamlessly integrated on plug and play devices for USB, PCI, PXI, Wi-Fi, Ethernet, GPIP or more. LabVIEW graphical development platform for design, control and test, embedded design and prototyping, industrial measurement and control, automated test and measurement. LabVIEW key features: hardware integration, 6,000 instruments from over 250 vendors, PCI, USB, Ethernet, serial, GPI, and CAN devices, modular data acquisition hardware from DC to the gigahertz range, motion control stage, cameras, hundreds of PLCs. Advanced built-in analysis and signal processing. Built-in analysis access thousands of engineering specific functions such as frequency analysis, curve filtering, fitting, and more. Inline signal processing interact with measurement and perform inline analysis in real time on acquired signal. Data display and user interface. Built-in controls interact with data using hundreds of drag and drop controls, graphs, and 3D visualization tools. Custom controls easily customize the position, size, and color of built-in controls or create your own sounds. Multiple target and operating systems, desktop and real-time operating systems. Develop and reuse code on Windows, Mac, Linux, and real-time operating system. FPGAs and microprocessor target various embedded architectures including IRM, microcontrollers, and FPGAs with the same graphical approach. So LabVIEW can run on Linux, Mac, Windows, and real-time operating system, and can be performed on portable desktop, PXI, micro and processor and FPGAs, embedded controllers, and vision system, traditional instruments. Multi programming approach, code reuse, integrated text-based code, and else. You can code by using C code, MATLAB. Also, various design patterns incorporate additional modules of computation such as dynamic simulation diagram and state charts. This is an example of how to data acquisition assistant from outside to the computer. Okay, LabVIEW is embedded design, control design and simulation, image and signal processing, industrial monitoring and control, software development and deployment, report generation and data storage. Embedded design, real-time module, FPGA module, microprocessor SDK, StatChart module, mobile module, DSP module, embedded module for ARM, C code generator, robotic module, control design and simulation module, bid and fuzzy logic toolkit, simulation interface toolkit, system identification toolkit, image and signal processing, vision development module, mass script RT module, advanced signal processing to sound and vibration measurement toolkit, modulation toolkit. This all libraries that comes with LabVIEW. You can download it and open it. Industrial monitoring control like SCADA system, HMI, OPC servers, multi-core programming, automatic and execution highlighting. This is an example for LabVIEW course, software development deployment. Required LabVIEW case studies. Lego, you can program it by LabVIEW. Current library hardware and color in the most powerful instrument on earth. This is fantastic. Okay, virtual instrument everywhere. More than 25,000 companies and more than 200,000 customers. 90% of Fortune manufacturing companies. LabVIEW vs MATLAB. LabVIEW and MATLAB can do the same process, but the difference is LabVIEW is coming from National Instrument, which has its own instrument that you can use, and you can use LabVIEW for programming it. It will be more powerful, more exclusive to use LabVIEW with this instrument. Also, LabVIEW offer you a lot of libraries that you can use to interface with any instrument you can imagine. It's also LabVIEW is a graphical programming language, so it's easier to deal with than MATLAB. But MATLAB is more powerful in matrices and arrays. So in matrices, if you are it's easier to use MATLAB in matrices and do calculation on matrices. But LabVIEW is the most diffused or interpolated programming language right now, and you can use it in many laboratories. Okay, how to run LabVIEW? if you this is the first button. Here you will find open LabVIEW with sub VIs. Start from an exam. Okay, if you see right here there the RVIs, and the project have the IV LV Proj. You can make a new VI virtual instrument and start coding, as we will see in the next lesson. Thank you for watching and subscribe for more videos. Thank you a lot, and any comment it's welcomed. Thank you a lot. Subscribe and follow us.